Session layer.
Then
Layer,
transport layer. Then
network layer,
Data link.
Data link layer.
Data link layer and then physical layer.
and then physical layer.
okay, very good. So what are the upper layers?
Application, presentation, and
layer,
session.
and session layer,
Application layer, presentation layer,
which is also known as software layer.
Software layers also. And lower layers?
Network,
Transport, network, data
and
link,
data link and physical.
data link
Physical
layer,
layers of
physical layer.
Physical layer, right? Okay.
Yes.
So yesterday we discussed about this. I guess up to session layer we discussed, right?
Yes.
Yes. So today we are having the last 4 lower layers. We'll be discussing about that. So transport layer, what exactly is the function? Okay. The transport layer.
Segmentation mainly.
I'm starting from today.
This is your first session.
Yes, sir.
Just remind me in the last 15 minutes. I will give you the
Yes.
notes. Okay. In the last
Yes,
15
sir.
minutes.
Yes,
Sir, even I want the notes, sir.
Okay. Just remind me in the last 15 minutes.
Yeah,
Okay.
absolutely.
Basically, this is what we discussed in the last session. These layers, OSI model. This is your topic, OSI, Open System Interconnection. So this application layer, presentation layer, and session layer, we have basically discussed that. We are coming into the transport layer. Now, transport layer main purpose is to establish reliable, unreliable type communication between two systems. Okay, connection. This machine must have a connection with this machine. Now, whether this connection is a reliable connection or an unreliable connection, this is what exactly is getting decided in the transport layer. Reliable connection means whenever this machine will send anything to this machine has to provide acknowledgement. Means he has to acknowledge that he has received that information. Okay. And unreliable means no acknowledgement will be given. Okay. Unreliable means when he will send any information to this machine, it will not send any acknowledgement. Unreliable. This is what we call connection oriented, connectionless. Okay. Connection oriented means that this machine, when he will send any information over here, then this machine has to provide an acknowledgement that he has received information. This receipt, it will provide it to this machine. And connectionless means no acknowledgement, no receipt. Okay, this machine will send information to this machine and that's it. This machine will not provide any type of receipt. Acknowledge. Okay, you are not acknowledging that you have received the information. Now, when we don't get acknowledgement, okay, once we send data to some machine, this is one problem occurs, confusion occurs, that whatever we have sent, whether this machine has received it or not, this type of confusion occurs. Okay, this is what exactly unreliable, connectionless, this type of communication is there. So these two protocols which works directly in this layer is your TCP and UDP. TCP, you can see it is connection oriented, you can say, and UDP is connectionless. Okay, so these two protocols directly work in this layer. TCP is considered slow, UDP is considered fast. Why TCP is considered slow? Number one reason is connection oriented and connectionless means TCP always gives you acknowledgement. When you use it, you are getting acknowledgement for whatever you're sending. And whatever you are receiving, all these things are acknowledgement based. Okay, but UDP doesn't provide any of these things. That is why it is fast. But the real reason for which TCP is slow and UDP is fast, it lies over here in the three-way handshake process. Okay, so if we understand connection oriented very carefully, this particular point, it should be easy for you to understand. Guaranteed delivery. Okay, guaranteed delivery is coming when this machine is sending something to this machine and this machine is giving acknowledgement that it has received it. Okay, this is kind of guarantee you are getting that whatever information you are sending, always this machine will provide an receipt, an acknowledgement. But UDP doesn't do any of these things. That is why connectionless, it is fast, and none of these things are happening. So the real reason behind which TCP is slow and UDP is fast coming with this particular process, this is called TCP three-way handshake process, everyone. TCP stands for Transmission Control Protocol. Always it performs this three-way handshake process between a sender and receiver. Okay. So suppose you want to send some informations to this machine. So first of all, you will be sending this packet. It's called synchronization packet. In short, we call it SYN packet. This SYN packet will be sent by TCP in this, from this machine to this machine. So you can see that arrow mark. This is the arrow mark, which is pointing the direction in which this packet is getting sent. So this machine wants to send something over here. This is when exactly TCP three-way handshake process is being performed between these machines to establish a connection oriented type connection. Okay, so what this machine is doing, it is simply just checking that whether this receiver is ready to receive the information or not. Okay, whether this receiver is available to receive the information. If this receiver is ready, he will send back an acknowledgement, and along with acknowledgement, it will send back a synchronization packet as well. The synchronization packet, this machine also will send, and it will come in this direction from the receiver side back to the sender. So this acknowledgement packet coming from receiver, it is the response of the SYN packet, because when this SYN packet is getting sent, this acknowledgement is coming in response to the SYN. Apart from that, this machine also is sending a synchronization packet. It is basically checking, okay, this machine is checking that whether the sender is available to build the connection or not. Okay, because ultimately the connection needs to be established, and it is for both the systems to understand that whether exactly the other system is available to build the connection or not. Both the machines, they are checking each other's status. Okay, so which one is available, which one is not available, this is what exactly is getting sent. Okay, it is getting decided over here using SYN packet synchronization. So if the sender is available, it will send an acknowledgement. If it is not available, it will not be sending acknowledgement. So third way basically completes this three-way handshake process. SCK packet means acknowledgement packet. All this three-way handshake process, once it is done, then it is declared as established. Means the connection is getting established between sender and receiver. And like what? In a connection oriented manner, they are doing communication. Means this machine is sending data, this machine is providing acknowledgement, like that always. So whatever data this machine is sending is providing the acknowledgement of it. All these TCP and UDP connections always are built on port numbers, everyone. This is when exactly we are having the port number range 0 to 65535. Okay, 0 is reserved. Okay, 0 to 1023, these are reserved for protocols like this. HTTP, FTP, TFTP, DNS, all these are protocols and services. For this type of protocols, this entire range 0 to 1023 is reserved. Okay, 1024 to 49151, this TCP UDP port numbers are reserved for companies who are into software development business. Okay, who build softwares like this Zoom application. The Zoom application is developed by the company. Okay, by the Zoom company itself. So they are being used in the network, they are used on the internet. Okay, so anywhere when applications are used to make communications in a network, this is when exactly companies, they're using port number from this range. These are chargeable port numbers, everyone. Okay, and this port numbers, what you are having, 49,152 to 65,535, these are basically used when your machine is sending any request to internet. Okay, dynamic, these are called dynamic range. Suppose you are accessing Google, then you need a port number. Okay, so we have two port numbers, source port number, destination port number. These informations are there in layer 4. Every single machine, when they send any informations to internet or to any network, they always include what exactly is that port number and to which port number they are communicating. Okay, so always the source port number comes from this one. So when you send request, your source port number always it lies in between this range, and your destination port number always it lies either from this range or this range. Okay, but this particular range always it is there when you are sending request. When you are generating request, always you are using a number from this range. So this is when exactly I have given you one chart. How many of you have noted that chart, that table? All of you?
Yes, sir.
You have
Yes.
noted that table.
Yes, sir.
So port number 2021.
Which one, sir? This one, yeah? 0 to
Port
120.
number, no, that I have given you the screenshot, right? From the web page. Remember yesterday?
Acha, yes,
The
sir.
common TCP UDP port numbers, right?
Yeah.
Yes, sir.
Common TCP UDP port numbers. This is what exactly you are having. Port number 2021 used for what? FTP, na?
File transfer protocol.
File
Yes, sir.
transfer protocol. It uses TCP, na?
Yes,
TCP.
sir.
Then port number 22 used for what?
TCP and UDP both.
Secure shell. na?
Secure shell. Yes.
Then port number 23 used for
Telnet.
Telnet. TCP, na? TCP. And you are having 25 port number you are having, right?
Yes, sir.
Simple mail transfer protocol. SMTP.
Simple mail transfer protocol, like that. These are the protocols what exactly we are using on a daily basis. Okay, so their full form is given over here. Okay, you can simply just, this is Telnet, which stands for Telecommunication of Networks, and SSH already you know, secure shell. This is the full form for this, and this port numbers we are using daily basis. Okay, so we are basically using all these port numbers in our TCP UDP communication. But the real reason behind the slow and fast always is over here. This TCP three-way handshake, okay, you are having it in TCP, but in UDP you don't have it. Okay, UDP doesn't have any of this type of scene synchronization, acknowledgement, nothing. Okay, that is why UDP is fast. So the main function of your TCP is what? Is to divide this entire big packet. Okay, big information, it is getting divided in small pieces. These are basically called as segments. Okay, and every segment is given a sequence number. Okay, so you can see that this is one segment, this is another segment, this is another segment, all these segments, small pieces, and these segments are being given a sequence number, like sequence number 1, sequence number 2, 3, 4, like that. All the sequence numbers are used by the receiver device to reassemble this particular information, because when this machine will send informations to this machine, it will be going in small pieces. Okay, like this small pieces it will go. So all these small packets, all these small segments, it needs to be reassembled to get this entire information. Okay, this is when exactly the sequence number series is used. Error control, flow control, these are the functions of your transport layer. Flow control is simply just ensuring that how much data this machine should be sending to this machine. Okay, over a certain period of time. How much data? Okay, whether it should send 1 GB over like what in 1 second or 100 MB in 1 second to this machine. This is the flow, data flow. Okay, it is basically ensuring that whatever like what this machine is sending, it has the capacity to receive it over a certain period of time. If this machine can receive only 100 MB per second data, and this machine is sending 1000 MB, then this machine cannot receive all the data because it is beyond its capacity to receive it. This is why exactly it is important to negotiate all these things, like how much exactly this machine should send to this machine, how much is the capacity of this machine to receive the data. at what data rate exactly he should be sending it to this machine. All these things are getting negotiated in this particular process, in the data flow, okay, flow control. And error control simply means that whenever any information you are sending, let's say that you are sending a packet from this machine to this machine, okay, you are sending some data, and this data contains errors, means this system cannot identify what exactly is this. If the system identifies that there are some errors in the data, it will basically, the transport layer will perform retransmission, means this machine transport layer will inform this machine transport layer to send that information again, means retransmission. Okay, error control, basically this is how exactly we are doing it, retransmission. So whatever information he has sent, again he will be retransmitting it over here if it contains any errors. Okay.
Can you repeat the layer 4 function?
Layer 4.
Function.
This is your function, na? These are main functions. Segmentation, sequencing, flow control, error control. Protocol switch is working over here, differences over here, TCP, three-way handshake processes over here. And these are your TCP UDP port numbers based on which we are doing communication on a regular basis. Okay. Now coming to the network layer. Okay, so network layer function is what? Two functions mainly, routing and providing IP addressing information to packets. Okay. See, we are having different names. I'm referring with different names. Sometime I'm referring data, sometime I'm referring segments, sometime I'm referring packets, sometime I'm referring bits, sometime I'm referring frames. All these names, from where it is coming? It is coming from here, everyone. Protocol data unit. These are the terms, what exactly we are using to represent data in different layers. Layer 765, we call the information as data. At layer 4, we call it segment. At layer 3, we call information as packet, not network. It is called packet.
Data packet.
Okay. Data packet. In layer 2, we call it frame. At layer 1, we call information as bits. These are different names given to different layers for the same information when they are going from one layer to another layer. Okay. So finally, in terms of bits, means zeros and ones. Okay. It is getting transmitted via wire. Okay. So we are having these physical cables getting connected. And in these cables, what is going on? Electrical voltage conversion to zeros and ones. This is what is going on. These are basically physical cables. And via these cables, your zeros and ones, these are basically getting converted into electrical voltage. And your informations are getting transmitted via these cables and it is getting received over here. Okay. So on the physical cable, this is your electrical voltage, which is moving, which is flowing via these wires. Okay. But at the system level, your electrical voltage is getting converted into zeros and ones in physical layer. After that, it is getting passed to data link layer, then network layer, then top to bottom approach, like that. At the time, lastly, at the application layer, it is getting represented. But network layer main function is two things: providing IP address information and determining the physical path so that informations can be sent to this machine. Physical path means in which path exactly this machine can send. Right now, I am having only one cable connected. If I have multiple cables connected to this machine, this is when exactly I have to choose one path. Okay, this is a path from here to here. This is a path. This is a route. Okay, this is a route to reach from this machine to this machine. If I have multiple cables connected, then which particular route is the best? This is what exactly network layer does. That it performs that function. Okay, finding and figuring out the physical path to reach the destination. Okay, to send your data to the destination. This is what exactly network layer is doing. And it is providing IP addressing. IP addressing means every single device's identity. If this machine wants to communicate to this machine, then first of all, this machine needs to identify this receiver PC. How this identification will be done? This is your IP address. Okay. This is your IP address, which is basically used for providing that identification to devices. Okay. Router, we are having, this is a dedicated network layer device, what is used for doing routing purpose. Okay, this is your router device, everyone. You can see this one, this device. This is the device which works directly at L3, layer 3 level. Okay, this device, it looks like this, and it does the routing. Okay, means it sends the packet from one location to another location via the best route. Okay, this is the hardware device, what exactly works directly at layer 3. So two major functions you are having. Okay, every single information we are representing at layer 3, it is called packets. Remember this, we are calling at layer 3, it is called packet. The main function you have is doing routing and providing logical addressing. Logical means IP addressing information to packets. So whenever he is sending a packet, then from which machine the packet is coming, to which machine the packet is going, this IP address information is provided network layer, by network layer. Okay, data link layer is kind of responsible for doing the framing process. Framing means whatever informations are coming from layer 7 to layer 6, 5, 4, 3, all these informations, it will wrap it in an envelope and it will give it to layer 1. Okay, just think of it like every single contents from layer 7, 6, 5, 4, 3, it is placing all these informations in a particular box and it is giving it to layer 1 for physical transmission over the cable. Okay, this is what exactly is going on. Okay, for example, suppose you are shopping. Okay, you are shopping in a mall. Okay, you have purchased different things from different shops. Okay, you are having a couple of bags in your hand. Okay, small, but all these bags, like smaller bags, you can basically place it in a bigger bag and you can make this type of like what you can carry this all these things, okay, in a much more convenient manner. Okay, you are just placing all these things in a particular big basket or something like that, and you can carry all these things. Okay, it makes things easier to carry when you are having a big bag comparing to multiple smaller bags. Okay, so just think of it like an envelope. Okay, just think of it like an envelope. You are putting all the informations in an envelope and you are finally sending it via courier. So this courier over here is layer 1, because layer 1 gives you that physical connectivity. Okay, so you are giving data link layer is collecting all the informations from all 7, 6, 5, 4, 3, and it is giving MAC addressing. MAC addressing information is required because this is the card control address. This pretty much responsible machine is communicating. Okay, always this is the NIC card.